So, hello everyone again. This is lecture 4 part 3 of alternating current. In the previous discussion in lecture 4 part 2, we have started with a discussion regarding sharpness of resonance, in which we understood bandwidth of resonance and now we are trying to understand the basic significance of delta omega and basically understanding quality factor concept. So, we will finally derive to that concept here and then we can move on to the next discussion regarding power factor. So, this is lecture 4 part 3 of alternating current. I am Sameer Lavankar. Let us begin our discussion. So, currently we are on the sixth topic, that is AC voltage applied to a series LCR circuit. After this is being completed, we will move on to the seventh topic, that is power in AC circuit, that is power factor. So, this was one of the concept which we derived in the last thing, which is bandwidth of the circuit. Please remember this. And second thing is that a measure of sharpness of resonance is delta omega, sorry, omega naught upon 2 delta omega. Then next we were deriving a concept using the value of omega 1. So, let us try to understand more after this point. So, finally, the equation which we obtained was omega 1 L minus 1 upon omega 1 C is nothing but equal to capital R, right. So, now as omega 1 is nothing but equal to omega naught plus delta omega, what we can write? We can write this equation as omega naught plus delta omega into capital L minus 1 upon omega naught plus delta omega into capital C, which is equal to capital R, correct. Now, let us keep omega naught out of the bracket. So, if omega naught is out of the bracket, I can write omega naught L into 1 plus delta omega upon omega naught minus 1 upon omega naught C into 1 plus delta omega by omega naught. I hope it is clear till this point. I am just removing omega naught from the bracket. Okay. Now, using omega naught square is equal to 1 upon L C in only this term omega naught. If you try to use this in only this part of the term, what we will get? We will get omega naught L into 1 plus delta omega by omega naught. I am keeping the first part as same only, but in the second part I can get this as nothing but equal to. So, if I write omega naught square as 1 upon L C, I will just get this value as nothing but equal to omega naught L upon 1 plus delta omega by omega naught. Okay. So, just mathematical calculation is being involved here. I did nothing complex, I am just equating omega naught square as equal to 1 upon L C here. Okay. So, after this is being done, next thing which is being obtained is nothing but equal to. So, basically to obtain this I just divided and multiplied by omega naught. So, this omega naught square is nothing but 1 upon L C, C got cancelled and therefore, L was being obtained in numerator, and because omega naught was already existing there, therefore, we got omega naught L in the numerator, right. And this was already there. So, there was nothing changed till this point. Okay. Now, little mathematical approximation is being involved here. So, now here if I write this equation again, this will be omega naught L, please understand this simple mathematical approximation, nothing new. So, it is 1 plus delta omega upon omega naught minus omega naught L into 1 plus delta omega by omega naught to the power minus 1, which is equal to capital R. Okay. So, now let us try to approximate this value of 1 plus delta omega by omega naught to the power minus 1. So, approximating one plus delta omega by omega naught to the power minus 1 will get this as equal to 1 minus delta omega by omega naught. Okay. Why it is happening? Since delta omega by omega naught is very less than let me write here. So, it is delta omega by omega naught is very less than 1. So, we are neglecting the all higher order parameters. Okay. So, approximating is already done. So, let us use this directly now. So, here after this we can obtain omega naught L into 1 plus delta omega by omega naught minus omega naught L into 1 minus delta omega by omega naught, which is equal to R. Okay. I hope this thing is clear here. So, in the place of 1 plus delta omega by omega naught to the power minus 1, we have just approximated it to 1 minus delta omega by omega naught. Okay. So, that thing being said, now the equation is quite clear. I can just obtain this omega naught L out of this equation, and therefore, I will get 1 plus delta omega by omega naught minus 1 plus delta omega by omega naught, which is equal to R. 1 gets cancelled, you will get the answer as omega naught L into 2 delta omega by omega naught is equal to capital R. Omega naught gets cancelled, we will get the value of delta omega as nothing but equal to R upon 2L. So, I hope this thing is clear to you, how we obtained that delta W is nothing but equal to R upon 2L. Let me write two different concepts here, and then I will reiterate everything which I just said. So, let me change the color. So, basically what is now sharpness of resonance? So, sharpness of resonance is basically given by omega naught upon 2 delta omega, which is nothing but equal to omega naught upon 2 into R by 2L. 2 gets cancelled. So, it is equal to omega naught L upon R. Please remember this very important term, that is sharpness of resonance is given by omega naught L upon R. Next concept is that this ratio omega naught L upon R is nothing but called as is also called as quality factor, denoted by Q of the circuit. Okay. So, this is denoted by Q of the circuit. I think let me stop till here only. I will just reiterate everything because it was a little large derivation. So, basically we started with this point here. First of all, we assumed a value of omega such that the omega 1 and omega 2 being obtained have a value of current such that the value of current being obtained is Im max by root 2. That was the first assumption. The second assumption, or we can say understanding, is that the value of omega 1 and omega 2 are basically linked together. Those values of omega 1 and omega 2 are basically omega naught plus delta omega and omega naught minus delta omega, which is being written here. Okay. Therefore, we obtained or defined a new quantity which is basically called as bandwidth of the circuit. This bandwidth of the circuit is basically omega 1 minus omega 2, which is nothing but equal to 2 times of delta omega. So, 2 times delta omega is basically bandwidth of the circuit. Next thing was again sharpness of resonance. So, sharpness of resonance is basically omega naught upon 2 delta omega. I explained you with some logic also why it is basically regarded as a measure of sharpness of resonance. Okay. Then we did a little derivation. So, this derivation was basically required to calculate the value of delta omega in terms of the series devices, or basically RLC whatever we get. Okay. So, first thing was we know that what happens at omega 1. So, at omega 1 there will be again a value of current. That value of current will be basically having an amplitude which is equal to Vm upon capital Z. That value of capital Z will be equal to root over R square plus Xc minus XL whole square. Now, this Xc and XL will be nothing but equal to 1 upon omega c and omega L, but we do not know the value of omega at that point. Basically, we do not know the value of omega 1, basically how it is being related upon. We know that it is equal to omega 1 minus delta omega, but we do not know exact value. Sorry, omega 1 plus delta omega, but we do not know the exact value because we do not know the value of delta omega. Now, next, because of the assumption which we put forward, which was that the value of I m being obtained is nothing but equal to I m max by root 2. Now, we know that the value of I m max is nothing but equal to V m upon capital R. Why? Because at the value of maximum current, the value of impedance is nothing but equal to capital R. If it is equal to capital R, we can directly obtain I m as nothing but equal to V m by R root 2, correct. That is also being done. So, now because both these equations are same, we can directly equate the denominators of these equations because numerator are same only. So, I just equated the denominators, and therefore, finally after obtaining, this was the last equation I obtained in the last part, which is nothing but that resistance is nothing but equal to omega 1 L minus 1 upon omega 1 C. Okay. Now, as omega 1 is nothing but equal to omega naught plus delta omega, what we did? We just in the place of omega 1, I wrote omega naught plus delta omega. Again simple mathematical calculations, I took omega naught out of the bracket, and therefore, we got a quantity which is 1 plus delta omega by omega naught. Now, to equate or basically relate the same in the same way, I just used the concept of omega naught square, which is 1 upon LC, or basically the definition of resonant frequency is only the second part of this left hand side. If I use this, finally the equation which was obtained is this, right. Now, using simple mathematical approximation, I approximated 1 plus delta omega by omega naught to the power minus 1 as nothing but equal to 1 minus delta omega by omega naught. There may be several other terms also, such as delta omega by omega naught whole cube, then delta omega by omega naught whole to the power 4, but because as value of delta omega by omega naught in itself is very small, all the square terms, cubic terms, or more polynomial terms will have a very small value, and which can be ignored or neglected. Therefore, after using this approximation, I got the equation which is equal to omega naught L into 1 plus delta omega by omega naught minus the omega naught into L into 1 minus delta omega by omega naught. Again, just taking out the common terms, we will finally obtain delta omega is nothing but R upon 2L. As we got the value of omega naught, I just use it in sharpness of resonance, which is omega naught by 2 delta omega, and therefore, the equation or the value of sharpness of resonance obtained is omega naught L by R. Okay. So, that thing is also being done, and second thing is that the ratio this omega naught L by R is basically called as quality factor Q of the circuit. Okay. So, therefore, that was the thing being obtained, and similarly we can also write for bandwidth also. So, bandwidth of the circuit is nothing but equal to 2 times delta W. 2 times delta W is nothing but equal to 2 times R by 2 times R by 2L. This 2 gets cancelled, we will get the answer is nothing but R by L. Okay. In other terms, I can also write this equation as omega naught by Q, right, because omega naught by Q is nothing but omega naught L by R. Omega gets cancelled, it is R by L, right. So, therefore, what we can say? We can say that the bandwidth of the circuit is nothing but equal to omega naught upon quality factor. Understanding about this more, let us say if the quality factor of the circuit is higher, the bandwidth of the circuit will be lower, or we can say that if the quality factor is less, then the bandwidth of the circuit is more. Okay. So, it is simply very easy to understand. If the bandwidth is lower, the quality factor will be increased. Okay. So, basically what we can say? We can basically say that the smaller the value of 2 delta omega or the bandwidth, the quality factor increases, and similarly opposite thing can also be understood. Okay. So, if the resonance is less sharp, not only is the maximum current less, the circuit is close to the resonance for larger range delta omega frequencies, and the tuning of the circuit will not be good. Okay. So, quite evident, you can understand this from the diagram also. So, let us try to relate everything. So, basically we are just saying that if this value of delta omega will be higher, if this value of delta omega will be higher, let me change the color. So, if the value of delta omega will be higher, if the value of delta omega will be higher, the bandwidth of the circuit will be higher. If the bandwidth of the circuit will be higher, the quality factor will be lower. If the quality factor is lower, we can also say that the sharpness of resonance is lower, and therefore more tuning is required for the resonance to occur. In the another sense, let us say if the delta W value is less, we can say that the bandwidth is less. If bandwidth is less, we can say that the quality factor is higher. If quality factor is higher, in similar terms we can also say that the sharpness of resonance is higher, and therefore less tuning is required for the resonance to occur. So, these all are different ways in which generally people talk about when the resonance concept comes into picture. Okay. So, I think that was important to understand here. So, basically we can say that resonance basically depends upon this device only, basically the value of ILR, etc. So, that thing being said, I guess this is also the end of sharpness of resonance. Let us try to understand one example here, and then we can move forward to the next concept, that is power factor. Okay. So, please understand this example very clearly, very easy, again only mathematical concepts are required and this can be solved very easily. So, the question says that a resistor of 200 ohms. So, basically R value is given to you in the question, and a capacitor of 15 microfarad. So, basically the value of C is given to you in the question, are connected in series to a 220 volt. The value of V RMS is given to you in the question, and 50 hertz basically says that the value of nu is given to you in the question, AC source. Calculate the current in the circuit, right. So, if you need to calculate the value of current, first you need the value of impedance, right. So, what is the value of impedance? Impedance is nothing but equal to root over R square plus XC minus XL whole square, right. As there is nothing given about XL, we can assume the value of XL is equal to 0. Therefore, as the value of XL is equal to 0, I can write this equation as nothing but equal to R square plus XC whole square, right. The resistance value is given to you as 200 ohms. In the value of XC, I can write this equation as 1 upon omega C, right. Omega can be written as 2 pi nu. Okay. So, just use everything here. So, this should be equal to 1 upon 2 pi C, sorry. So, finally, after everything being obtained, I can get the value of XC as nothing but equal to 291.5 ohms. Okay. So, this is the value of resistance being obtained here. After this, second concept just involves the value of current. As nothing is given to you, please calculate the value of RMS current only. What is the value of RMS current? It is nothing but capital V by Z. As value is given as 220, so it is nothing but 220 divided by 291.5, which is nothing but equal to 0.755 amperes. Okay. The second question says that calculate the RMS across the resistor and the capacitor. If the algebraic sum of these voltages are more than the source voltage, then resolve the paradox. Okay. So, paradox is a second lateral part. Let us first calculate the value of RMS voltages. Okay. So, let us understand it very carefully. Here the value of VR, how to calculate the value of VR? VR is nothing but IRMS into the resistance, correct. The value of current being obtained right now was 0.755 amperes, right. If I multiply it by the resistance given here, that is 200, you will obtain the value as nothing but equal to 151 volt. Okay. So, I am just leaving the mathematical calculation for you, you can just do it and understand by yourself also. Similarly, what is VC? VC is nothing but equal to I into XC. What is XC? XC is capacitive reactance. So, XC obtained is nothing but equal to 0.755 into 212.3 ohms. Okay. Therefore, this is nothing but equal to 160.3 volts. Okay. Now, if I do a simple algebraic sum of both of these voltages, I will get the answer as equal to 311.3 volts. If you see clearly, the amount of voltage being applied was 220 volts, but the value of summation which we obtained using using let us say Kirchhoff's loop rule, or let us say by simple algebraic sum, we are getting an answer as 311.3 volt. How it is coming in this form? So, I think this is the answer till this point. I will try to resolve this paradox in the next part of this lecture series. So, it is similar same concept only, there is nothing new here because of phase difference or phase difference between the capacitor and the resistor. This difference is coming here. I will try to resolve this paradox. Till now, let us understand till this point only, in which we are getting the values as 151 volts and 160.3 volts. The values are same, values are correct, but we will try to resolve the paradox in the next part of this lecture. So, let me stop it here only. This is the course progress. We have completed the introduction part, AC voltage applied to a resistor, representation of AC current and voltage by rotating vectors, AC voltage applied to an inductor, AC voltage applied to a capacitor, AC voltage applied to an series LCR circuit, and after this is being done, we will move on to power in AC circuit, which is power factor. Okay. So, I think on the example is already completed, only 2-3 points are to be explained, and then we move on to one of the most important topic, that is power in AC circuit, that is power factor. So, that is being said, thank you for this lecture. We will meet in the next lecture, in which we will try to understand first the paradox, and then we can move on to the power factor concept. So, thank you.